Good afternoon, everyone. Thanks for attending the Freddie Mac KPMG Big Data session. We are very super excited to share with you our success story with Big Data Journey. I know it's the last day of the conference and people are anxious to get home. But this is my first attendance to this conference, and I can tell you that it's been very exciting to listen to all the new products, capabilities, and experiences. Just kind of opens doors to a lot of new possibilities. As Hercule Poirot would say, the gray cells are working overtime, at least in my head. So I am Lakshmi Purushothaman with Freddie Mac, a senior director in the single-family credit analytics and reporting team. And co-presenting with me is Kevin Martelli, the big data technology enablement director at KPMG. We initially partnered with KPMG to help us to develop the technical solution. So as we go through this presentation today, I'm going to share with you who we are, what are our business challenges, why we decided on big data technology and tools, and what was the reason that we decided on a data engineering framework, and of course, what was the final outcome. So let me start with who we are. So Freddie Mac is in the secondary mortgage business. We make home possible for millions of individuals and families across the nation by making home housing more affordable and accessible to home buyers and renters in communities nationwide. How do we do this? When a borrower goes to a lender such as a bank and submits a loan application, then the lender underwrites the loan and provides the loan to the borrower. Freddie Mac then purchases those loans and thereby making the mortgage capital flowing into the industry so that the lenders can then take the so then the lenders have capital to give more loans to qualified borrowers. What we do is we then pool those loans and sell them as mortgage-backed securities in the open market. As many of you heard in the Tuesday session, one of the panelists mentioned about 1-minute mortgage loan approvals, right? So as the industry is moving towards faster loan production origination process, Freddie Mac launched a set of integrated online tools, what we call as Loan Advisor Suite, to help drive the quality of the loan manufacturing process, thereby increasing the purchase certainty and operational efficiency. So how do we do this and how does it benefit our lenders and borrowers such as you? Is when you use the Loan Advisor Suite, it helps the lenders, guides them through the loan origination process every step of the way, all the way from the beginning to the closing, and it gives us a lot of information about the data that they are using to underwrite the loan. What this means to the lenders is that they can now use this information for greater purchase certainty, and the borrowers, they're getting an improved customer experience, as well as both lenders and borrowers save time and money into each step of the way. You may hear a lot more about this as we start rolling out a lot of new products in this space. The entire industry benefits from improved loan performance, and we increase our market share. So how do we do this? We are committed to using the big data tools and our advanced analytics experts in creating powerful enhancements to our Loan Advisor Suite, so thereby we can help address the challenges of today's market and reshape the way how the industry works. So what was our business challenge? So the credit analytics reporting team that I'm part of, we have to have data. We needed data as soon as the product was launched so that we could actually assess the impact of that offering in the loan origination process. We want to be able to assess the risk that is, for Freddie Mac itself as we are trying to provide decisions back to the lenders. We also want to be able to give actionable feedback to our customers to increase the adoption of our new tool suite. We want to extract knowledge from these data sets so that we can identify new variables and metrics which might be better predicators for performance so that we could continue to innovate our products. And we also want to enrich our algorithms for quality control as well as fraud analytics. So our need for this data just continued to grow exponentially as we started launching new products. As we went through this process, one of the things that we realized was, if you have all been a homeowner or have been part of a home ownership loan process, you could imagine the amount of data that is getting collected, right? As a borrower, income, your assets, appraisals of the property, all this data has to be collected, and we need to look at all this data. They come in different formats, different types, as XMLs, JSONs, Word documents. So we need to be able to analyze the data from these types of data sources, and then we also have to integrate this data with our rules engine system, which shares data using XML files. So all our upstream applications, our interface files are all XML. So we have to integrate that data. Then we also have to be able to integrate with third-party data sets that we want to use to gain more insights. So to do all these things, we needed some kind of a framework that would help us to enable and wrangle this data much faster. I mean, it's common knowledge that data wrangling takes about 50 to 80%, right? We've all heard about it, but we want to beat that. We want to be able to do this so fast because our products were getting launched every day. Each system was launching new things, and how do we catch up with them so that we could actually be ready with reporting at launch. So our current state in 2 years back was we were about 6 to 8 months behind. So we need to get to, at our boss's dictate was, I need to see the data as soon as a product is launched. So to do this, we had to look at some of these components. First one was reusability. So as I mentioned, we had multiple applications. So we need to, any framework that we built, we need to be able to connect to all these different subscribers with very minimal change, right? So that was a key critical success factor for us. Extensibility. So as our data sources changed, this framework, APIs and connectors have to work with a JSON, XML, PDF, OCR documents, and of course our standard relational data sets. So that was another metric for us. And then of course cost. When we did our first project in 2015, as I said, it took us about 6 to 8 months. We can't sustain that kind of a model, both from a cost perspective, because the number of resources, it was linearly growing, and the time, right? We can't continue to say we're going to be 8 months out. It just was not sustainable. So we came up with an ideation project that basically kicked off brainstorming what can we do, how can we make this work for us and meet our business objectives. We started with a tactical approach. We tried to go and run our algorithms in Hadoop against the raw data files. That didn't go very well. We couldn't get any insights out of it. Then we tried to look at legacy tools, such as Informatica and other things. While it would have helped us, the timeline didn't meet our needs. So then we decided we were going to build something that we wanted to have the flexibility and the control to make changes as we found new things that we need to add to our framework. So the key thing for our framework was a self-learning, highly flexible, common data engineering framework. So I'll talk a little bit about the self-learning later. But as we go through the highly flexible part, you'll realize why we are saying it. We're going to show you a video as well as to how easy it is to make a change and then get to the result set much quicker. So as I mentioned earlier, our success metric was we got to give the data to our data scientists as well as our analysts much shorter time. And our output was for 3 use cases. So we got to be able to give it for this data set was in Hadoop for our data science work. This data set also had to be in our MPP platform for our business analysts. So, and we had a reporting requirement as well, our standard risk committee reporting. So all 3 use cases had to be solved with the same framework. Yeah. So once we've decided that this was the engineering framework that we wanted to build, we of course want to make sure it's not a custom one-off solution that's sitting in somebody's desktop. So this kind of shows you that our framework actually works in an enterprise setting which connects to all our sources that I mentioned earlier, as well as the data standards and controls is the backbone. So as a data owner, application owner, as well as a member of the data standards governance group, I have to ensure that the framework should comply with all our data standards and governance, and as well as security. Kevin will talk a little bit more about it later. But it is something for us to keep in mind as we build this framework. And this is the part we're going to focus on as we go through the slides further down. So why did we do this? As I said, we wanted to think about how do we design the solution. And here is one of the examples. So this data set, as I said, was not built for consumption for downstream users. It was an interface system to system sharing information files. Here is an example. So when we looked at this XML file, it's kind of deep in its container formation, as well as we have identifiers that are actually from 2 different systems, which I'm sure you're all familiar with. But one is actually from our selling system, and one is from our underwriting system because they're talking to each other. However, there is not much information for us to know that this is from this system. When we look at our metadata, it just says it's a loan identifier, right? It doesn't say which system it is from. But our reporting requirement is that we need to be able to get the loan information from our underwriting system. So there are 2 ways to do this. In a traditional path, you would be looking at a business analyst trying to go and get their analysis done outside of this project, come back with the requirements or a user story that tells you, oh, I want you to go and get this information from here, and then a developer would go code that, right? That's pretty standard path. So in our case, what we would do, we're going to show you as we go through in the next few slides. So here is another example of our XML. In this, we actually have dynamic containers. So to keep the flexibility for the upstream systems, they had used a lot of dynamic containers where the data, as you can see from here, container 5, has, in this case, a Boolean value. And then in this case, it comes up as an indicator with a, these are 2 different sets of files. In the first one, the container 5 has an integer, and here it has a Boolean. And in the second one, we actually have 2 container ones with 2 different types of data sets. Now this information, these data attributes actually have different data types, different min-max values, different meanings. So when you have to convert them into relationalize them, they actually become into columns in your table. Again, if we have to do this, we can do it manually, but it's going to take you a lot of time and effort to do something like this. Our XMLs also contain a lot of empty containers, one-to-many relationships, and as well as deep nested setup. To kind of wrangle this kind of XML is when we decided we have to do a data engineering framework that would allow us to make this much easier on us and shift the burden from our data scientists. So the 3 things that we came up with at a high level is data discovery, business rules, and data model. And these are all much familiar items for anyone who has done data warehousing, data mart. But how we applied that in our Hadoop environment is what makes the difference. So let's start with the first step, data discovery. So as opposed to a business analyst going and trying to build a data dictionary and coming up with requirements, in this scenario, we asked Hadoop to do it for us. It's as simple as that. So today when the Oracle's presentation in the keynote speaker said in the second principle, let your algorithms help you to identify and continuously learn so that it, right? That's exactly what this is. So basically, we wrote our Spark code that goes and looks at the source XML and creates a data dictionary for us. It tells you what is your path, what are your attributes, how many occurrences you have, and it continues on it to show what could be the possible relationships that your data has so that you can decide whether it's a parent-to-child relationship or whether it is a one-to-one relationship. So this is generated as a config file by our code, irrespective of what the source is. You just put the source, run the code, and that's what Kevin is going to show you a little bit later. The next step is business rules. So now, not only do we want to keep the first manual step automated, we want to give our business users the ability to add their requirements, right? Again, it's a second deliverable in your life cycle, but here it's in the same document, same place. So the business user comes in and says, oh, you know what? I only want the loan's original status. I don't want the current status in the XML. OK, fine. Just add it into your config file. I want to be able to just look at addresses that are exact match and not a type match. Fine, we could do that here. So they just, in English, they basically add, of course, with certain keywords into the same document. And we have lots of examples here that kind of gives you the variety of business rules that a business user can get into it. Then comes our data model. So once we have the data dictionary, the relationships, the business rules, we as a team can easily look at it and create a data model off of it. So once we have the data model that tells us, so to get to this stage in your traditional path, you're talking about months. In hours, you're talking about a couple of days to come to this stage. So we actually are able to get to this from an unknown source with not knowing the data landscape about that source file, much about it, and come to this stage. So what we do is we then take this model, actually add it back into that same config file. So now you have your discovery, your business rules, your transformation rules, and actually your model, meaning it tells you this attribute actually has to go to this table, right? So everything is in that place. It's as simple as that. I know it sounds very simple, but yeah. So this is really the aha moment. I know it looks very simple, but this is what it is in a very high-level conceptual way of showing the stuff. Sorry, yeah. So is that you look at the 3 inputs all being created by the PySpark program, and what differentiates us is leveraging the machine learning as well as in the future AI to help to have the continuous learning part here. So as we are doing, we're telling this, adding in this configuration model, we're telling the code to say, oh, take this data and put it here. Think about it. If our data sets and we can train the model, it can tell you tomorrow, I think this has to go here. So your data modeler really doesn't have much to do. They may just do an overview and say, yeah, it really looks right, right? So you're shifting your focus on the reporting side and reducing all the time around the data munging process. We're hearing a lot about a deep learning and machine learning on the final data set, but here you're actually doing that upfront during your data wrangling process. So now I'm going to turn it over to Kevin to go through the technical architecture and the demo.
Thanks, Lakshmi. I just wanted to touch on a few different points on the slide, because I think it's relatively important. I've been working in the Hadoop space for a long time, and it tends to be you throw all this data into the Hadoop cluster, and everyone's kind of doing their own little POC work, and then it never goes anywhere. And then you're trying to search it. You have Elasticsearch on top or Solr. You're trying to find the data, and again, there's discrepancies, and it's hard to find. I think this process here that was generated, with Lakshmi and her team and the KPMG team, where it's unique is And I really want to focus on the extensibility of the framework and how anyone can leverage it, right? It's not just unique to Freddie or unique to this organization, but it's a unique way to drive through the value of the data that we're seeing through this data munging process. And if we looked at here on this, let me go back one, sorry. On this XML, this is just an example of sucking in an XML as one semi-structured type. It could be a Word document, it could be a PDF, et cetera, just expanding on that framework. And one of the challenges were there were hundreds and thousands of XMLs. And because the XMLs really had no formal structure, they were all sort of open containers, they could have a tremendous amount of value in them, or different values in them. So what this process is doing here is as it's sucking in all this information, it's taking all of your XMLs, all your XSDs, it's going through your Python program, and then ultimately feeding it up here into this box. Now within this box, you can have an end user, and the idea is to eventually wrap around like a web application where you're sort of integrating in, you're looking at the discovered data sets as Lakshmi showed prior, you're looking at your business requirements, and then you're starting to add it into what your ERD model will look like. Ultimately, you're bringing it back into the enablement. It's creating that full end-to-end cycle from data discovery, data identification, relationalizing the data in a way, to data usage. So the time to failure or success is so much quicker by being able to go through one of these types of frameworks. And I think Lakshmi hit right on the point here, and this is something we've been exploring, is how can learning come in, right? I mean, we all hear about machine learning and all these different sessions, and it all sounds really nice, you know, automated cars and all these things that are someday out there we'll be able to achieve. But how can we maybe have something more immediate in the future? And what we started learning was, now granted, we didn't have a tremendous amount of training data to sort of get to where we wanted to get to, but as we're starting to understand this information that's coming in from the end users, which is significant, can we start taking some of those learnings, apply them back into the machine, so now instead of just getting out sort of a blank report, it's starting to identify where some of these relationships are. It's starting to identify where maybe some data discrepancies are. How can we start applying this for more practical, tangible purposes where, again, 80% of our workload is in this area? Imagine how quick it would be if I go to a business user, I give them a UI, they can go explore all the data in my cluster, pick the fields that they want, relationalize it, and then have action to it right away. The time it takes down is tremendous. The next slide here is really just highlighting really the main components that we talked about before. Again, we want to highlight a little bit on this ingestion part. So again, ingesting the data that we took in from a raw or our bronze data set, any types of ingestion, it's going to be handled. The data discovery, and then the access of the data, the API to flat file. But again, one point I didn't hit on that prior slide here was around data profiling. I think it's critical to understand the profiling of the data, not only from the time you bring the data in, but as your data is going through your different levels of maturity. How does that data changing? Are there new outliers you need to look at? And all of this is built in a configurable, manageable way, so there's no need to kind of redo these same processes for different data sets. This next picture here, again, goes in a higher level. It talks through what our data, just want to check for time. It talks about what our data profiling mechanism looks like. Very similar to our configuration framework that we had on the other page, where we're having different types of profiling that gets put into the profiling engine. And one important thing I did want to call out is that while we're profiling the data, and we have like these 3 different sets of data, which at this point was what made up our XML files. But as the data is going through the evolution of maturity, so here we have like an enable data, or some of you may call it a bronze, gold, silver data. It's important that as it's continuously going through these levels of maturity, we're adding and enhancing across our profiling. Our profiling is not there to only help us get good data at the begin with, but more importantly to get the data sets after it's being produced. And one of the challenges we saw at Freddie was that they get a lot of real-time data in from third-party systems. And this real-time data that's coming in is historically, it gets put into their organization, they run it through this big rules engine, and then it spits out results. Well, how can we prevent the bad data from coming in to begin with? What are the mechanisms that we can put in play? Can Kafka, as we saw today, can that play a mechanism to maybe stream some of this in, give real-time results before we start landing the data? And as we all know, once you land the data, it's a nightmare to get the data back out. This next slide here, I apologize, the view doesn't come up that well, but I just wanted to kind of show the overall architectural framework that we put together as part of this platform. It's been a very consistent reference architecture that we were sort of able to build. for different purposes. And I'll just quickly highlight a few of the items. So Scoop has been pretty successful, and many of us have probably used it, ingestion from relational data stores into the cluster. And kind of the heart and soul of this is what we're using here is Anaconda for Python and IPython Notebook. But as we start reading in these XML files, one thing I don't want to underestimate here is that these XMLs are extremely complex. Probably many of us in the audience can say, give me any XML document, I'll flatten that and get it for you, no problem. But the challenge here is how are you relationalizing those XML documents? How are you getting them so they're meaningful in the analytics that the team needs to produce? And part of this is going through a little bit here what we're doing in our PySpark. So again, we create our RDD documents, element trees to start breaking down the XML structures, ultimately pushing it over into resilient distributed data set, RDD. But this is ultimately what gets fed into our enabled tables. And this is the configuration file that Lakshmi has sort of talked about. The configuration's fed into these processes to ultimately drive the process. And again, it comes back into our machine learning libraries where a lot of our data profiling is being completed. Hive is our ultimate output table, but it doesn't preclude us from pushing it out to other analytical downstream applications. Historically, a lot of us might push out from the cluster into like a Vertica or into a Netezza. We're pushing it out in this scenario to Actium Data Matrix, which is an MPP system, and connects into some of their legacy tools. So the point I don't want to lose out on is that this is fully automated using all the inherent tools of HDP. We used Uzi, Kerberos. They have Atlas integration into Informatica, Ambari. The end-to-end framework here is being leveraged to fully automate, industrialize, and productionalize this app, where it's running day in, day out, errors are being notified, and downstream applications are dependent upon it. So I think the maturity that we're seeing, especially with Atlas that we've heard this week, and the maturity of these tools overall, although I think initially it was, things didn't work and you had to change the config file and move somewhere else, but they're becoming more and more mature. And just like many of these tools, they're all being configured through some type of like XML file. And that's the same way that the framework works too. It's working off the same exact framework that a lot of these cluster tools are working off of. So the embedding of the framework into the cluster is easier to work. This next part, was there a question? No. I just want to show a quick video. We have a few minutes left. Here. So what this video that we're going to be showing on is we're going to take you through the ingestion framework that we did. And it's going to go through the discovery phase. It's going to be adding the business rules. It's going to be running the model and ultimately outputting it into Hive. This is to show the real simplistic of how simplistic this worked. But I think the important part is as we start overlaying the UI and the technologies on top of it, think about how all these teams are seamlessly now working together. You're not passing off documents to different teams. You're all working through a single user interface, worked through for approval, but the change management process is significantly reduced.
For the same house. We only want to extract and output the valid address into our Hive tables. Looking at this file,
this is a standard XML
it has
file
two
that we have
addresses
seen
with
in the
different
past.
values
You can
for
see
certain
it's rather
fields,
complex in
such
nature.
as geocoded
It has many
indicator,
different
address
types
level type.
for the same loan.
To facilitate business
how does
to
the user know
develop their
what is the correct
requirements,
address type?
we build a data
How do they tell?
discovery
There's different
program using
attributes that can
PySpark
help
to
attain
mine
that information.
historical files
You'll
on
see
HDFS
geolocator,
to get potential
you'll see
values,
exact
occurrences,
match field.
etc.
But
for each
again, look at the
XML
highly
element.
nested structure, all of the
This
complexities.
output will be the
And
base
these
of
are
our data
thousands and
model.
thousands of rows.
Now
How's the
let's
user
kick off
supposed to
our
understand
discovery
what
program.
that loan document is?
Depending
And
on the
what we're
volume
showing
of
here
the
is we're
data,
executing one of
it
the
might
programs.
take a
And what the
while
program's
to
actually
get the
doing,
output.
it's going out across all of your XML, all of your XSD documents, pulling out those values, and then it's trying to come up with the data discovery document that can ultimately be used to help you gain the insights into the particular file. So
which provides the data elements and related
and I apologize for
statistics,
the view
for
here.
example,
It's going to
number
come up
of
a little bit.
occurrences,
But this is basically
unique
the data
values,
dictionary
etc.,
of
extracted from
what is
historical
coming
data.
out of the system.
We see that
So it's showing
geocoded
you the
indicator
attribute
only
names.
has true-false
It's also showing
values,
you the
and
occurrences of
address
the
match
attributes,
level
how many
type
times
has
has
4
the value
values:
occurred,
exact
is
match,
the value
median
true
match,
or
type
false,
match, and no match.
what are all the different values that
Such
can be
information
there,
helps the business pick the
the
right
types
values.
of values.
Next, we
Now
build the
this is
data model
ultimately
from the
what the
data
business will
discovery
use
output and
to then
business
again think about
requirements.
it on a
The
UI
model
part, filling in
configuration
these on
file
the UI,
specifies all the
identifying what
data
fields and
elements
tables they
table
want.
names,
Then they'll
data
come into the
types,
configuration
transformation
file,
rules,
and they can start
filter
defining
rules.
what they want their data fields to be.
Here is the
What
filter
data
to
fields do I
extract
want?
the
What data
address
elements
which
do I
has
want? What are the
geocoded
type of my
indicator
elements?
equal to
What are
true,
all my transformation
which
rules
is
that I
the
need to
scrubbed
do?
address,
What are some of my
and
filters
address
that I
match
need
level
to add?
type
In
equal
this
to exact
scenario, what you'll
match.
see is we're changing
Decoupling data model from
transformation
file
rules because we
parsing
want to
makes
say,
our data
pick up that
enablement
first
process
address. The
applicable
first address,
to
based on what we're
different
seeing
types of
here,
XML
is the
files.
most
In
relevant
other
address.
words, we only
And it
need to
goes back
change
to
the
the
model
comment
configuration
around
accordingly
data
when a
science and
new
machine
file
learning.
schema comes in,
If we
while
know
the file
that this is the
parsing
correct
module
address all the
remains
time,
intact.
can we
The file
automatically
parsing
pick
module
it based
shreds
on the
XML files
sampling
and
data that
loads
we're
the
getting?
results into hive
And
tables
what we'll see here is
based on
that
model
based on the
configurations.
parameters that
Now
were
let's kick off the
chosen,
file parsing
the user
program.
then will be able to go through, they'll run the report, and then what you'll see
Again,
is
it may
the
take a
hive
while to
table
get the
created
output, depending on how
where
much
that
source files it
value
is
of
processing. Due to the limited
the
length of
address
this video, let's skip
was
waiting and check the
ultimately
output.
selected, which unfortunately
Specifically,
the
let's
view
see
is
if we
not really
extracted the correct
that
address.
great. And the next one just alters the XML document to show
In this
you
table,
the
we
same
do
thing.
see the scrubbed address
I think
there.
we just have a few more slides, and then we can jump into questions.
Now, for demo purpose, the values in the source file.
So one of the other areas I just wanted to quickly hit on was around
We run the file parsing program again.
security.
Now the results table
And
contains
Freddie Mac, similar to KPMG, being a financial service,
the other
being
address.
a
Our
firm
filter
that's
works.
in the financial service industry, security is utmost importance, right? And how do we gather the right security and controls? I think we can all agree that we know Kerberos, we know Ranger, we know TDE, we know the Uzi automation, et cetera. But I think the real meaning of what we wanted to show here is that these tool sets are at a level now where you're able to fully integrate into your existing frameworks without causing much of an overhead, or I guess I should say impact. And the final slide, I think it was two more, but one last slide here is, and this goes back to what Lakshmi was sort of referring to earlier. And what we wanted to try to call out here was there's two different models of doing things. You've had your traditional data warehousing where, granted, you may have a lot of data in your EDW, but if you don't, you're going back to your source systems. You're doing data identification. You got to do profiling, mapping. You got to understand your business rules. There's a very succinct change management process. It's not as easy as going into one place. So as we're dropping the data in Hadoop, as long as you're identifying it properly, you're tagging it the right way, and then you're having these accelerators, such as this common data engineering framework or other things, you're able to sort of accelerate the time to market or time to fail by going through these processes, getting your gold data, and then really running your analytics, where you want your data scientists and business analysts to run through. So with that, Lakshmi?
So so as I mentioned earlier, we evolved over the last couple of years. But I'll just focus here. So recently, in the last quarter, we had launched a new product. And as soon as the product was launched, we were able to get to a report the very next day. So what was the business impact was that as we saw the data, we realized that the business outcome was much different than what we had expected. So there was some issue in our upstream system that was causing that behavior. We were able to quickly go ahead and change, fix the issue. So if we had been here, we would have taken 9 months for us to identify. Whereas today, we are able to do it the next business day. And delays in resolving such a type of issue would have been a customer dissatisfaction. Our data engineering framework is well proven because we've been able to implement it for 6 to 7 subscribers and has been gone through 3 product launches. Some key takeaways, since this is enterprise adoption, we wanted to kind of reiterate that yes, it is possible to have a big data solution that's enterprise ready. Leverage the big data platform and tools, again, to do all the work that we manually do in terms of data engineering. The potential is just endless. You could use machine learning and other things to do all these activities. And then continuous learning continuously helps you to get more insights around your data and its relationship. Were we able to reduce the cost? Absolutely, yes. Because if we had continued our model, we would have kept staffing a lot of people. I do want to take a second to talk about my team. So the team, my team was a group of business domain, data, and technology experts, but mostly in the traditional tool sets. We had some foundational knowledge around Python and Java. But the key thing was that, and of course we have a lot of statisticians and mathematicians in the team. But with all that, we felt that we could make that bold move into big data space with not really having a lot of Spark experience. We did get Kevin's team's help to do that initially. But our overall learning curve was much less than what we had anticipated, given the foundational technology skill set that we had. Reusability is very critical, and although it's a short presentation, if you're interested, we can talk a lot more about it. Every component is modularized so that we could reuse this component across in many different areas like the data profiling. We have a factory pattern that actually lets you to use it for different subscribers. Multi-tenancy, I think you all kind of heard yesterday's keynote speaker, right? It depends on your pattern, how the usage pattern is, and what kind of resource allocation. So that is still a bit challenging. So it depends on your organization and how the use cases are being used in that Hadoop platform. And that's the end of our presentation. So thank you. And there's one thing I want to say, that the data, with the big data tools, I think we can definitely transform the ETL process and reduce the data engineering. Thank you. It's the second one. So because these were interface files, sorry, the question was how did you infer the relationships about the data, right? Because that's what we wanted to get out of this, and that was really with the algorithms that we used in our data profiling. So what we did was, when we apply the rules, it kind of tells you the number of occurrences, what is the correlation. So we had all these algorithms that would actually go through that data set and then tell you, for this variable, these are all the things around it. And that gives us an indicator of what would be the relationship and the place of that attribute.
Does this verified by a human after that?
Yes. Today it is by human. That was the domain expert. So we let the business and the data expert look at that output, and then they could override it if they think. For the business team? Oh, I mean, it took us, the first time it took us, because we were learning, right? We were trying to do this. It took us about 3 to 4 weeks, I would say. But for the current new product launches, it takes us about 2 to 3 days. It's actually not full time. They're there for a couple of hours, and they go back and come back, kind of.
But one thing I will say is that the XML it was extremely nested, and there's other companies looking at how do we flatten it, how can we get the relationship. And to Lakshmi's point, there was algorithms that were used, but to your also first point, the SXDs helped us to say, okay, here could be some fields, and here are the values, right? Just to kind of frame it out. But then to get the actual values, we had to look at almost every single XML document, right? And then start applying those values to the XML. So it wasn't an easy task. And once you have all those documents are based in their containers. Users can start choosing what they want to do. Now the onus is on the user for how they want to do it, because we'll develop the table how they want it. So for instance, we were just talking the other day, you could have 2 address files. Well, suppose you want 2 address files, but you also have 1 loan that has 2 address files. You can do that. You don't have to have EKK as a loan. You can have 2 loan IDs with 2 address files. And then again, with the flexibility at this point, it's on the user. So just imagine, if you have this data, any other data, you go into the system, it brings up on a GUI, shows you all your data. As a business user, you start building your tables on how you want your tables and your transformation rules. Take this out, put this in. Now they're seeing it, and there's no IT involvement. There's no IT change. It's there for them to see it. Now once they grant it and they see the results and they want to display it, but it's amazing how many people are still using XML. And how far along it still is, but the nesting is where the complexity comes in. Anyone can flatten. Can you read it?
Yeah, to add to that, we mined 9 months of data. Again, through this program, right? It mines the data about 9 months to identify all possible patterns, then presents it to us. Yes.
Yes, that was in that one document.
Yes.
And that helps the people understand it.
Frequency, distribution,
variety,
correlation. everything was one of those selectors in our document. So you could say, I want to run all of these against all the variables. That's kind of because it's big data platform. Or I can say I want these 3 combinations for this. And tell me what it is.
Last question. What is the size of the data?
Sorry?
What is the size of the data set?
The total data sets right now is about 3 terabytes, and it's growing as we launch our
All the
products.
XMLs are just a blob in DB2.
Yeah. Sorry.
Okay.
Yeah.
Did you have one question?
I think there were 2 questions we can talk.
Yes.
No.
It's not a mandatory,
Yeah.
it's a requirement in the sense to help generate that data discovery document.
How long did it take for you to develop those algorithms which can actually then mine out of the vast XML?
For all of them. For the config?
Yeah.
6 months?
Total project length was about 6 months from design to implementation, so it would have been about 3 months just coding initially.
But what was ironic, one thing Lakshmi left out, her team, so they would be a bottleneck a lot because the business would say, hey, we need all this stuff. And then Lakshmi would have to run all around, get all the information, and configure it. Now she's actually accelerating on the other side because the other sides are building products and things, and they're saying, hey, we have these test documents we're building everything off of. She can run it through our process and start calling out issues in how they're building XML documents before the documents are even built because the processes already exist. So it's like instantaneous turnaround of, before it was wait till we got everything, test it, we find issues, go back, and then the pyramid, if she's capturing it like almost at the requirements time, the change is a lot less. Yeah.
Yes, we are very proactive. That's why when I said 2 days, it's that we could give it back to them much faster than where we were before. Yeah. Thank you.
Feel free to
Yeah.
add a couple
Yes,
questions
yeah.
here, but I need to take my
Yeah.
calls.
Do you want to unplug it?
the computer.
Would it be possible to connect with you guys on